Yeah, hi there. In this time series tutorial, we are going to cover simple exponential smoothing. So before we proceed towards simple exponential smoothing, so you remember in simple moving average, what we did basically, we took the window. It could be 3 months or 6 months or 12 months, and based on that, we calculated the average, and that was used as a parameter to forecast for the future. Now, in simple moving average, what we did, we assigned equal weights. Basically, we gave equal weightage to all the values, whether the value was a recent value or the old historical value. However, in the real time, we observe that the values which are nearby to the time period for which we are doing the forecasting, those nearby values should have a higher say or should have a higher weightage compared to very old historical data. So this is what is done in the simple exponential smoothing. It gives more weightage to the nearby values and less weightage to the values which are older values, based on which we do the forecasting. So for example, in simple exponential smoothing, what we do is, let's say we have to predict for the time period t plus 1. So y hat t plus 1. So y hat is basically we are going to predict. So anything we are going to predict or forecast, we represent it using the hat symbol. So y hat t plus 1. So we are going to forecast for the time period t plus 1, and y hat is the value that we are forecasting. So its value will be basically alpha times y1 plus beta times y2 plus c y3 and up to so on. So where a plus b plus c up to k. So basically these are the weights. So what we are trying to say is where yt is the most recent observation and y1 is the most oldest observation. So what we want to do, we want to give more weightage to the recent observation. So k is basically a coefficient, or you can say a weight, which is associated with the with the observation. So k will be greater than the other weight, and similarly so on. So basically a is less than b is less than c, and so on. So a is basically the weight or the coefficient for the oldest observation that we have. So it will have the lowest weightage, followed by b, and so on. So the idea is that if you want to predict or if you want to forecast for a time period t plus 1, then you have to give higher weightage to the values which are nearby to the time period t plus 1. That is the nearest one is obviously the value at the time period t, and then the value at time period t minus 1, and the value at time period t minus 2, and so on. So we give higher weightage to the very nearby values and low weightage to the older values. So that's the overall idea behind the simple exponential smoothing. So simple exponential smoothing technique, this is also known as single exponential technique. Okay, so so there is a term called as a level in it. So basically when we say level, so it is defined as following. So LT, so level at a time period T, LT, this is equals to alpha times YT plus 1 minus alpha times LT minus 1. So LT is basically a level component at the time period T, and this equals to alpha times YT. So YT is the observation at the time period T, and alpha is the smoothing parameter or the smoothing coefficient that we give. So what we are saying is that the weightage that we are passing is alpha, and it is multiplied by the recent observation yt, and and we are adding to it 1 minus alpha, that is whatever is left out. So 1 minus alpha, for example, if alpha is 0.2, then 1 minus alpha will be 0.8, and that will be multiplied by lt minus 1. Again, this is the level at time period t minus 1. So level at t minus 1 will be again following the same formula. We get alpha yt minus 1 plus 1 minus alpha times lt minus 2, and so on. So if you see, this is nothing but a recursive formula. So ultimately, if we put all these values together, it looks like this. So the value y hat at the time period t plus 1 equals to alpha times yt plus alpha into 1 minus alpha times yt minus 1 plus alpha into 1 minus alpha square yt minus 2 and so on. So where alpha is the smoothing parameter or the smoothing coefficient and its value is between 0 and 1. So if you see these coefficients, these are actually in the exponentially decreasing order. So we have alpha, then the another coefficient is alpha into 1 minus alpha, then another coefficient is alpha into 1 minus alpha squared. So these coefficients are in exponentially decreasing order. So let's take an example. What we are going to do is we are creating a data frame in which we have the quarters like Q1 2017, Q2 2017, Q3 2017, Q4, and so on. We are taking it for the year 2017, 2018, 2019, and we have the sales value for each of the quarters. So that we have created a data frame here. Now we have to first create the level. So how do we create a level? For this, I have just created a simple function get level. To this, what I'll do, I'll pass a series and then the alpha value. So series S, for example, in this case, I'll be passing the actual sales, this value, this particular column as a series. Okay. Now level, the first element of the level, I'm assigning it equal to whatever the first element of the actual sales is. Okay. And going forward, the level at the time period or level at the index will be equals to alpha times the value observed plus 1 minus alpha times the previous level. So in this case, so what will happen, there will be another column called as level, for example. Then that level will have a first value as 80 and the next value will be alpha times 130 plus 1 minus alpha times 80 because 80 would be the first value of the level. So using this, I'm just calculating the level for each of these. So if I do this and then the forecast basically at the time period t plus 1 is nothing but the level at that particular level at time period. So so using alpha values, so what I'm doing is now is I'm just passing the different values of alpha. For example, I'm starting with alpha 0.2. So what I'm saying is I'm giving weightage 0.2 to the most recent observation. That is, if you see this formula, alpha is 0.2. This is what I'm passing 0.2, and it will be multiplied by the most recent observation. And 1 minus alpha is the for the other observations and so on. So we have alpha 0.2. So I think I'm just creating a new data frame SES, which is a simple exponential smoothing, which is initially having the copy of the data and adding a new column as level, which will get its value based on this function. So to this function get underscore table, I'm passing the sales value. This is actual sales, and I'm passing alpha value 0.2. So it will return the level values that will be assigned to the level column, and the forecast is the previous value which is there in the level will be become the forecast value. Okay, and then I am just plotting it. So we have the actual value and the forecast value. I am plotting it. So if you see this blue color, this is the actual sales for the different quarters, and this is the forecast. Now, now changing the value of alpha to 0.3. If you see, rest of the things are same. This is the actual, and this 0.3 is slightly up compared to the previous one, 0.2. Now if I give 0.5, that is I'm giving 50% weightage to my recent observation, then it will follow more similar pattern to the actual one. And if I give a very high weightage of 0.8%, then it will be almost similar to whatever initial actual observations are. So this is what the crux of the simple exponential smoothing is. Basically, we have to give weightage to the most recent observation, slightly higher weightage, and the older values will have a lesser weightage. Now we know that a time series data, it primarily consists of three components, that is level, trend, and seasonality. So the simple exponential technique, basically it helps us to capture these three components one by one. So we'll start first understanding the simple exponential smoothing technique that helps us in capturing the level of the time series data. So for this, I'm importing simple exponential smoothing from statsmodel.tsa.halts winter. So from statsmodels.tsa.halt I'm importing simple exponential smoothing. That's the module. Now again, I'm just using the same airline traffic data. This is the same thing that we have done multiple times earlier. That is reading the data, setting the columns, index, and creating the train and the test data set. Now I'm just setting the training index as basically just to make sure that it is in the date time index. Now we know in the simple exponential smoothing, just we covered that yt plus 1, that is at the time period t plus 1, the predicted value or the forecast value y hat will be equals to lt, where l is the component at the time period t. Now what is lt? Lt, we know, is equals to alpha times yt plus 1 minus alpha times lt minus 1. It's kind of a recursive in nature, where alpha is a smoothing parameter value between 0 and 1. Okay, so how do we do this? How do we start on this simple exponential smoothing to capture the level? So first we have to create a object. So object, in this case I'm setting it as a model. So model equals to simple exponential smoothing. This is what we had imported. If you see above, we imported simple exponential smoothing. Okay, so simple exponential smoothing, and I'm passing to it train passengers, that is from the train data the passengers column, so it will create a model. Now I'm just fitting using smoothing level equals to zero point 0.2 and optimize its fall. Basically, I'm not asking it to do any optimization. I'm just giving, because I'm passing the value zero point 0.2 to it. It will fit it and store it in another object model underscore fit. Now we can print the parameters. What is the parameter that is having? Now what we have to do? We have to do the forecast. So I'm taking test.copy and storing it in another data frame y hat ses, where ses represents a simple exponential smoothing. So in that particular data frame, I'm adding one more new column, ses underscore forecast, that is the forecast for simple exponential smoothing, and it will have a value coming from this model fit. So model underscore fit dot forecast. So I'm doing a forecast for the length of test. That is the number of observations which are in the test data set. I think around 24. Yeah. So for 2 years of forecast. So it will do the forecast. Now I'm just plotting our train train data set, test data set, and whatever the forecast that we got. So if you see, this is our train data set, this blue line. Okay, test is this orange one, and this is the level which is the forecasted by simple exponential smoothing, that green color. So this is how we use the simple exponential smoothing to extract level of the given time series data. We'll cover more other details like extracting other different components in the next lectures. Thank you.